welcome everybody to this webinar around throttling and peer-to-peer, something that we know a little bit of something about. We have two people on the call presenting. It's myself, Andreas Hammarskjöld, based in Sweden, and another Swede not based in Sweden, Johan Arvidmark. Do you want to introduce yourself, Johan, a little bit?
Absolutely, as Andreas mentioned, and thanks for having me, Andreas, I should say. My name is Johan Arvidmark. I've been working with the 2-point team now for 6 years coming up. Started back in 2019 as an engineer and have kept on having that role since, helping out with implementation, testing, for concepts, things like that. But prior to that, I've been a consultant all my life. Worked with primarily config manager back in the days, a lot of imaging. These days it's a lot of Intune work and autopilot and other fun things, but all the things have something in common. They typically use network in some capacity. It's really hard to distribute anything without any network. So we're going to share a couple of tips and tricks for you here today, and also give a preview to what's in our absolute latest release here and on the platform. But one thing Andreas and I have in common is we absolutely love questions. So if you do have any questions, don't hesitate to post them here on the Teams call. I just noticed that the Q&A functions seem to be available, so use that one if you can, because they have a lot of queuing mechanism, so that should work. But otherwise, the chat, we'll keep an eye on it. So that's me, I think.
Yeah, and the first question that came in, which is basically if this will be recorded. Yes, it absolutely will be recorded and put on our YouTube channel. So if you have to leave, whatever, you don't have to be fearful of losing things. You can go back and look at the recording later. So thanks for that introduction, Johan. My name is, as I said, Andreas Hammarskjöld. I'm one of the founder of 2-Point Software, and we've actually founded the company based upon our findings around Microsoft peer-to-peer technology. So with something that since the start of the business has evolved a lot, we'll probably dig into some of that as well today. But if you have any question that we don't cover, doing this within an hour is a pretty hectic time slot because there are lots of things to go through. We do have an agenda. It's not very enormous. I think we'll waffle over a little bit who 2-Point Software is, or what they are and what we do. Setting a scene, which might take a little bit more than a minute or two, but not so much. And then hopefully we'll have plenty of time to demos. And if you have questions during the demos, just put them in the Q&A. And if we get you on to finish early in his demos, that might not be, we'll try to set aside some time for a proper Q&A at the end of it as well. So without further ado, let's take the easy part. 2-Point Software is a software company that primarily focuses on helping organizations with complex scenarios. Typically what complex means is distributed environments with lots of branch locations or satellite links or poor network connectivity, or enormously large companies with big main offices with up to 10, 15,000 devices in a single campus network, etc. So we write software components that extend and work together with the Microsoft platforms typically, but not only that, but like we're also expanding into the Linux side of things. But it's a lot around protecting the network and favoring the other payloads that should go across the networks. Linked with that is, of course, OS deployment, because that is one of the heavy lifters of content. If you're deploying anything, whether it's Windows updates or a feature updates to hundreds or thousands or hundreds of thousands or 500,000 clients at any time, there will be a lot of network traffic. With this, we try to get as much content that we can, or visibility in real time. That is also somewhat hard, because if things are hitting the network, you probably want to know about it straight away, not after the fact. which a lot of the reporting that is built into the functionality focuses more on what happened yesterday or even last week rather than what is going on currently. Linked with this, sadly, is also a lot stream of work that we're doing. It's around recovery of devices, primarily for organizations or things where ransomware or other types of disaster scenarios have struck, where things needs to be rebuilt from more or less advanced complex scenarios like rebuilding machines from home or over poor network connectivity. But another way of explaining what we do is like there were a bunch of old people that have been around the block so long, so we're trying to get across what we've learned to our customers. I think the first fully automated remote deployment that I did of operating system deployment was around 2005. We did, 82,000 machines using SMS 2003 and the OSD feature pack, going from Windows 2000 to XP. And all of those 82,000 machines were distributed, I think, around 2,000 physical locations in the United States. So people didn't believe that the technology was around to do that then. And even today, people are hesitant to actually not put servers everywhere. But the technology really actually works to do this kind of thing.
I remember that release. I was on site at Bella Center in Copenhagen just before Christmas when at the IT Forum they released the feature pack for SMS 2003, as you mentioned, and they did the first wall of fire demo ever. They lined up an entire wall with computers, 100 of them, thick screens before flat screens, and they reimaged them in like 10 minutes live in front of 4,000 people, and it was beautiful. I remember Bill Gates and Bill Anderson were on stage, and Bill Anderson asking Gates basically, if this demo failed, will I get fired? And the answer was yes. But that's how I saw the feature pack live for the first time. So I was quite impressed that you guys were able to get that in actual production within 2 months, give or take?
Yeah, it was pretty rapid. I was lucky to be on the pre-release versions of it, so I knew what it could do before that. But yeah, it was pretty shaky. So the previous way of building machines was actually using Ghost. Do you remember Ghost?
Yeah, and yeah, I do. And PKI deploy was also in the mix somewhere.
Yeah. Beautiful. So things have moved on. I don't know if it says more about our age than it does about anything, but let's be quiet about that. Today's topic that we're really going to dig into is two things, and they kind of go together as a horse and carriage. One of them is the throttling of content transfers to basically reduce any congestion by slowing down the speed, and i.e. making it taking longer time to download the content. And the buddy to the right side is the peer-to-peer side of things, who's responsible for reducing the content size that needs to go over any sort of network. Typically, it will always go over a network, but the local network is typically always a lot faster than from the source that you're pulling it from, whether it's limited by the server resources or by the network in between. So these two are what we're really going to be covering mostly today. And if we take throttling first, I just put some bullet points down. The main sort of key issue around throttling today is that it's still very much a per device configuration item. So if you have thousands of devices in the same location, there might be a fair amount of bandwidth, but if all of them are allowed to go free fall, basically that will potentially overwhelm a network. But if you start limiting, if there's no traffic on the network, it will still limit that device to actually pull down the content. And there are lots of things that have come into play around allowing us to do smart things like LEDBAT and LEDBAT++, and together with the R LEDBAT, which is in Win 11. But most of that and other congestion pieces works that it's basically dropping packets. So as packets are dropped, whether it's the application to tell to drop a packet or something else, that will basically tell TCP to slow down the download. A lot of the time you think when you're downloading something, it's that the client that is pulling something, but that's not really the case. It's the client that is receiving. So all of the sending mechanisms are controlled by the server side, which can actually be quite troublesome depending on, because the server might not know that one of the client is across a really slow link. So it will happily try to flood that to go as fast as it can. And there are lots of things like QoS and other tools out there. The problem with some of them are that they're very blunt tools. HTTP, which most of the content is being transferred in today's enterprise, is also used for a lot of other things. So putting a basic QoS policy into throttle HTTPS is not going to be very popular. And then you need to start controlling which endpoint should have this QoS policy, etc. So they're not always the best tools around it, but we'll dig more into that. And to back up, probably around, oh geez, what is it now? Probably close to about 13 years when we started working with branch cache. We had an old tool, which was the branch cache bits reporter, which gave us these nice diagrams of a download. So what you're seeing is here is a traditional, and you can actually see it's old because the computer names are actually Win7. So we know it's old when we see that, right? But it gives a pretty good explanation. One client basically pulled down the content from a config manager distribution point, and all of the other guys pulled down everything from the first guy, right? Or even from each other as it spread. So you have one copy across the network instead of like 10, which it makes perfect sense, right? But then, like the Socrates, who was a smart guy, he had a paradox, which is basically, you don't know what you don't know. So what we started seeing was that we were starting seeing some funny results. And we thought we were basically chasing a bug. And I'm going to take you through a lot of this, what this really meant. But to explain it a bit further, like if we compare the native peer-to-peer technologies with some of the things that the StifleR product that we develop, there are two elements that comes into this bug scenario that we're going to talk about. It's what we call a red leader, which is what we use to try to dedicate bandwidth and to improve peer-to-peer, and the throttling per location and network, which we'll be covering hopefully in Johan's demos as well. But basically what we saw was, if we looked at this report, you can see that a lot of the clients, basically even if they started at the same time, they basically pull down a lot of content from the distribution point themselves. So the peer efficiency wasn't so good. And then we can see that as it's ordered by efficiency to the right, we see other clients that really, they perform really well. So why did this first batch not perform well? And what was really going on? Like something must have happened to cause this result. This is very different to what we saw earlier. So we started digging in and we looked at another report, which basically gave us the indication that the first machines that had poor performance, they had started at pretty much the same time in the beginning, and then you had a second batch. So the second batch, they're all the guys that got everything from the peers, and the first batch is the bad guys that didn't perform so well. But we still didn't know what was causing it. So we started digging into like detailed logging to figure out. And like anything more technical, you read and you read and you learn and you learn. And I would say that it wasn't until probably 6 years later I truly understood the real reason behind why we were seeing what we were seeing, which is a long time, right? But basically, as in most cases, when you try to find a bug, it wasn't a bug. It was basically a feature that we were seeing. but the feature caused it to be behaving in a certain way that made the outcome really bad. So what we saw was in this case, we were using bits together with branch cache, and they have a feature called flash crowd, which is basically a protection mechanism inside the branch cache logic together with bits that detects that other clients are downloading the same content. So as all of these clients started at exactly the same time, they all go in and ask, like, does anybody else have this content? And they quite quickly learned that, nope, nobody has this content, right? So they actually went to start download. But because they were downloading at the same time, basically, they were more or less kept in perfect sync. So it wasn't until, and if you remember from the slide or with the graph, you had that it was peering some. So it basically started peering when this flash crowd happened. And then from there on, it was good, but it was slow. So what was really causing this? Well, it proved that the developers at Microsoft had put in some really cool features to detect that other clients are downloading content as well. So Branch Cache learned that, hey, other guys are downloading the same content. Therefore, I shouldn't go and get my content. I should wait long enough. It didn't kick in into the beginning. So there instead you had competing downloads because they ran in perfect parallelism to go get content, download it, ask any peers for it. Nobody had it. And it wasn't until they realized that there were other clients where they formed up behind in the queue. But that really led to the slowness, because once we were able to figure out how we can form and basically help to create these flash crowds, it meant that if we have a default sort of per client throttle, let's say we have 100 clients to make math simple, each one of them is assigned 101 megabit each, right? Which is a total of 100 megabits. But when the flash crowd forms, it becomes sort of one natural leader that does the download and the sharing. But since he's limited to 1 megabyte, the whole network will not go faster than 1 megabyte. If they were all competing, they would use like what you saw with that when they were all pulling it from the peer, or not from the peer, from the DP, then basically you would get a full 100 megabit use. But all of a sudden the flash crowd formed, peer efficiency goes up, but it's then slow. So what we wanted to build, which we started working on, was then how can we naturally assign more bandwidth to one guy so that the other learns that he is the natural leader. We should not go and compete against him, but let him do the download, and we will more or less on a packet level be caught up behind him. So if he goes away and like a laptop moves, somebody else will take over. And the efficiencies that we saw in this was quite staggering, right? So if we take these 100 megabytes or megabits that were assigned to the machines, if we can then assign one guy to get 75 megabit and the other guys can share the rest of the 25 if they need to, basically the performance improvement was basically almost 75 times compared to what you would have naturally. So this might come across as very technical and an issue, but it's something that applies to more or less every type of peer-to-peer technology that there is. There's something that needs to keep track who has what and how much bandwidth are we allowed to actually put over the network. It's the same with bits and branch cache. It's the same with delivery optimization or any other peer-to-peer product out there. And then you need to know what you're working in. Otherwise, basically, you're going to be fighting not a bug, but fighting the feature. And fighting features is a lot harder than fighting bugs. So hopefully that was enough waffle to make you fall asleep. And we'll wake you up with some amazing demos by Johan.
All right, let me go ahead and steal the screen, and thank you, Andreas. Setting the scene. Can you guys see this okay?
Yes.
Oh, fantastic. So one of the things that lured me into the whole 2-point ecosystem was back in the days, the capability to see what's going on with all this traffic and all this peering, and also being able to manage and control it. Since then, the products that does this, StifleR, that platform has expanded to do much more than that. I'll give you a little preview of some of the things that's been added in recently into the platform also. But this is a dashboard. It's a server stack that takes care of all the data and all the management part. And then there is an agent out on the client that does the reporting in and the control mechanisms to make the traffic flow the way it should flow, so that we have like the best peering possible. So as you can see here on the dashboard in my little lab here, and I will show you what it looks like shortly, I'm doing pretty well on delivery optimization. At least I'm above 80%. It's not the best, but it's not the worst either. But I could certainly do a little bit better on config manager traffic, which is here in the bits downloads. And as you can see here also, there is a lot of traffic that you may not think happens on your devices through bits, for example, but actually happens in the background, and we make sure to visualize and show all that. But before diving into the configuration here, I made a little visual diagram. This is what this particular lab network looks like. So I have a couple of data center locations, these guys here. I have a couple of regular, what I call like client locations, client VLANs, where we have Windows 10, Windows 11 clients. I have a bunch of clients on Wi-Fi. I have a couple of more clients in Seattle and a couple of VPN clients. The reason for showing you this is that to get the best experience of content, you would typically want to apply different settings to a client VLAN, to a server VLAN, to a Wi-Fi network, and to a VPN network. Think of it. If you have 50 VPN users that are working from home, so 50 different homes in different parts of the world, you typically do not want them to peer content to each other. That is probably not the most effective way to get stuff done. But if you have clients in an office, you definitely do want them to share content to each other. You want them to share that as effective as possible. If you have data centers, they are often like really, really well connected. So you may not want to throttle that traffic much, but at least you want to see what's going on. So you can have that ability. So in StifleR, and I took the liberty of making just one more slide, and I promise we'll be done with slides. We have basically a hierarchy. We have locations, we have network groups, and we have networks. This is just how we bundle things together so that we can apply good configurations to them. So if I go back to my dashboard here, head over to my network node, check my topology. Here I have a couple of locations. Within each locations, I have one or more network groups. And within each network group, I have one or more subnets. And it's typically on the network group where we make the configuration. So I can either affect one subnet or many subnets at the same time. And in the early versions of StifleR back in the dark ages before 2020, it was pretty much do the configuration on that unit itself. But since then, it's been evolved, and we work a lot with templates instead. So if I head over to my administration node here, I have network group templates that I have created. So for example, here I have a template that I'm using for one of my data centers. It's a well-connected network. And I have some throttling configured just for demo purposes, but normally you would have much higher value in a data center. But this will control the behavior of that network group and all the subnets that belongs to it. If I go to one of my other templates here, like this one here, which is assigned by one network group or one network group here, I'm doing a little bit more. First of all, there is throttling going on. But we are also making sure that branch cache is configured the way it should be. And we're making sure that delivery optimization is configured the way it should be. So basically, all clients that belongs to this topology is getting the settings from this template. And if I need to change something, I just update the template and pretty much immediately, real time, that takes effect on the clients. So this template is applied to a network group. I happen to have a client in one of these network groups, and I just wanted to show you what that would look like on the client. If I go over here, head over to one of my Chicago-based clients, and I will ask it nicely here in PowerShell, okay, what is your current DU configuration? Well, it's like this. And these settings come from that particular network template. That could be one configuration that is dynamically applied to all clients, but we can do better. We can even provide things like infrastructure. We can tell that, yeah, not only should you throttle traffic reasonably well, but this particular location should also be using a cache host. That's a technology you can add in, either together with a config manager distribution point or together with a standalone cache server. This happened to be a standalone cache server that is managed through Azure to some extent, but we control where the client should talk to get cached content, because this is really, I get excited about this, but having an agent on every device allow you to dynamically apply the right changes as network changes. And that's really the trick to get good throttling and get good peering out of a system. And also to see what traffic that happens on that network. So if I, for example, go to a VPN client here, one of my VPN clients, and check the DO settings there, you see they are being configured to simple mode, meaning do not peer. By all means, throttle if needed, that you can do that, but do not peer, because you don't want to do that. And that is a template that is assigned to a VPN network that does that. So if client would move into an office, it will be assigned a different template, different settings. If this one goes to Wi-Fi, different template, different settings. If this goes to VPN, different template, different settings. So that is basically what the platform does, making sure that the client is assigned with the right configuration depending on the network it happens to be at that moment. And that is really, really hard to do without a platform that controls that behavior. Now, if I want to go to one of my network group and just see what's going on, I can either drill down into a specific subnet, or I can say, okay, I want to see what's happening on these VLANs here. And I can see I have 24 clients at that network at the moment. And as you can see, it's currently not doing particularly much at all on these 24 clients, but let's go ahead and motivate them a little bit. So I go ahead over to my config manager server. Could have been Intune as well. We work with that content too. Could be Autopilot. We work with that content too. But in this case, it happened to be config manager. So in this case, I'm using a healthy dose of PowerShell to basically blast deployments out to clients very, very quickly, because that generates, well, network traffic. So let me just find the VLAN that actually has, there we go. So here is a collection of machines, 24 of them. And I'm going to ask PowerShell nicely to basically nuke their caches from orbit. So they are clean, they don't have any content, they are just fresh machines that never downloaded anything ever. So give that 10-15 seconds to run, and then we can go ahead and actually initiate the deployment to them. And this is really healthy when you're testing out technologies like this, to have quick ways to basically reset the scenario and then try again until you have the configuration that you like the best. But anyhow, once that is done, here I have a list of config manager packages that I want to deploy to these 24 devices. So I'm going to pick a couple of batches here, packages. And no, let's just do a single file here. Single package would be good. Not sure why it shows it in different colors at the moment, but seems to be happy. There was some coloring going on there. Weird. Anywho,
it's green and red. Most men are colorblind in green and red. Johan, you know that.
I did an eye exam recently. It's one of the perks of being an elderly geek. You have to do these yearly checkups, and that's one of the things they do check. So, but it's been a couple of months. I have to give it that, so that can happen. Anyhow, I have a script block here with packages I want to run. So I'm just going to go ahead and do that. So, boom. So I just started up a bunch of jobs, config manager deployments on a bunch of clients. And obviously we won't be able to see anything until config manager starts to do anything. But once config manager does, we will start to see that traffic coming in the dashboard. So if I go back to that dashboard, we can keep an eye, and we already see traffic coming in right now from these clients. And this is what you're looking for, these coloring. So for example, since this is config manager downloads, I'm really interested in this particular color here, because that is how much they appear. And the more you have of that, the better. So you can see that this is a protected network. It is configured to not go over a certain limit. We are making sure that traffic is not going over that limit over the WAN link. But on the local network, in between these clients, they can go as fast as they can or want or whatever they need to do. But you can see here that my branch cache ratio is steadily going up. And this is possible because this particular template that was assigned to this network group is of that type regular that Andreas referred to earlier. And I like to call it a queuing method, but it basically makes sure that one of these 24 clients gets most of the bandwidth first. So why is that? Well, so that that client can put the content in its cache so it make available for all the others. So the other 23 machines, they're almost like put on like a holding pattern. It's like, wait. And now then it's like, okay, go. So that is how we can get these much higher peering efficiencies on networks. And you have this real-time visibility to everything that is going on. And you can start to drill into like, okay, how much is actually going on? We can look into each individual download that is happening on the network, and we see how that one is behaving, what bandwidth that is currently allocated to that client. So here you can see that my red leader, this little friend here, is indeed getting way more than all the others. And this is because I assigned it to that template. Have I picked a different template, like one of the well-connected ones that I probably will use for the data center or for a deployment network, you will see a more even spread among the clients. But this is optimized for peering. And it's the dashboard and the agent that makes this possible. Now, in addition to seeing all of this stuff here, we have ability to see other fun things like ongoing autopilot deployments, a lot of together with our integration with StifleR as well, will be covered in a later webinar here, and we have some other upcoming webinars too. But we can, for example, see imaging going on. We can have generic sequences going on. Say that you have a complex application deployment. You may pre-deploy packages out there. You will see those in real time as well in the environment. Another fun metric that not too many people know about is that not only can we control and manage what's on the network, you can also see the biggest offenders on the network. And this is kind of fun when you go into a new customer environment, because they often have an idea, okay, what is it that is generate most traffic? And then we pull on some metrics and show them this is actually what's going on the network. This is what's using the most bandwidth at the moment. And sometimes we will see like a video surveillance system using 80% of the network. And the network team keeps blaming the config manager admin for loading the network. And it's like, no, it's config manager using like 10% maybe, but there's something else using it. So even down to the different application types, you can get an idea on how much is being reviewed, retrieved and sent for those networks. Other things that is possible in the platform is to take a little closer look on a client. This was not available when I started in 2019, but it's been available as of late, and even more so in the recent version 2.14. That is latest version, I should say. So if I want to search my client, I can do that. I can just type in a part of a computer name. Could be the end, could be the beginning, doesn't matter. But it will show me those clients, and this will show me them quite quickly. So if I click this client here, I get a lot of details about this machine. And again, this is real time. So for example, I get information about admins on that device. I get connection details if there are any on that device. This is not so exciting because I don't have a wireless client on this one, but I can have one that I can show later that have that. We have cache information, we have details about the network, what's going on that client at the moment, some nice little statistics, and either some application data on that client specifically. Okay, which are the applications on this machine that is using most of your network. And I also have this, let's see if I can get my friend Zoom it over here. I happen to like that little utility a lot. Oh. Here we go. Pretty much this column here is where the magic happens. If I expand that, you can see that there are all sorts of remote activities that I can do on the client. And for example, if I open up the event log, it opens right away. Have you guys ever opened the event log on a device in recent years? Like going to the event log and clicking here and waiting for a week, and then eventually get some stuff that you can work on. This one is instant. It's a very fast viewer. I have File Explorer, I can peek into the file system. I have Registry Viewer, can peek into the registry. WMI, if I want to check all the WMI classes on a client. And again, this is all real time. I can view log files, I can get performance counters. Here we also have some upcoming features that we're adding in, like task scheduler and users and groups. And I can do a remote session to them. I can run command file, I can run PowerShell scripts directly on the device in real time. And we added this already back in the 2.10 version of StifleR. And one of the feedback that came back like right away, like, okay, I really want to be able to delegate this to folks. So like I can have a help desk like persona, and they will be able to do this and this and that. And in the earlier versions, we didn't have much of that, but we do now. So something that is fairly new in the 2.14 version is that you have an administration node. You see your admin users, but you can also define roles. So here I have a remote admin role. And if I edit that one, here I simply have enabled, okay, this particular role, what is it that that role is supposed to be able to do? And then through a rule, I can assign that to groups. So if I go back to my role here, you can see that it indeed added to a group through a rule mechanism here. But long story short, it means that members of that role will have access to those things. You can also toggle that on or off on individual clients if you want to, but usually this is a great starting point because this is managed centrally. And that segues me into a feature that I am maybe shows a little bit how much of a geek I am, but in early versions of StifleR, when you needed to do a change on the client, on the server, often it involved loading up an XML file in Notepad++ and make that change and restart the service. And I consider myself a little bit of an expert in fat fingering said XML file, restarting the service, and then it won't start. And I was scratching my head, what was wrong this time? Oh yeah, I forgot to have an end, slash in a XML tag or something like that. So what happened both on the server side and on the client side is that the configuration in the backend, there is a configuration tool for it. So for example, we have one for StifleR server itself, where we can do that configuration. Advanced or general information available. And it makes it so much easier to apply configs and make sure you don't fat finger something. You can import, you can export, and even more elegantly, you can verify that the information you added in at least has a fighting chance of working, and then it restarts the service. And we have this on the client side as well. So if I go to one of our clients, like this little friend over here, head over to the installation folder of SAD client. There is a configuration tool here. That will have the client configuration, which server to use, etc. And here are the remote tools specific stuff that I mentioned earlier. That is possible to toggle on the client as well. And this information, like on the server, you can import and export. So for example, here, I have a couple of different configurations that I can apply. So when you deploy the agent from either Intune or Config Manager, whatever you prefer to deploy from, you basically deploy our MSI together with the configuration file that will apply the right changes. This one can also be run after the fact if you want to change something on the client, but this is just so much easier compared to have to update these XML files like we had in earlier versions of the product. So, and this is pretty much across the board of our platforms that you have a configuration editor that will make sure that the settings that you apply are healthy and okay. And yeah, I like this.
And you'll be soon moved to the web as well, so you don't have to work with the local app as well, so that we push the same config through the server itself.
But make it a little bit simpler to do these things, so for the good. All right, do we have any questions coming in? Other than
I don't think so. I had one question that I asked, replied back to, whether the caching will work with Arc in the near future. I assume they mean Azure Arc and not the Arc, the browser. But I didn't get a reply.
Well, I don't know of any current integration with Azure Arc, unless Andreas has a magic secret hidden.
No, but I would assume that they're doing their downloads using either bits or with DO. So I would be surprised if they're doing something else. Oh, I think we have a reply. Yeah, so it was Azure Arc. As far as I know, their downloads are using bits or DO for it. So
But
then, yeah.
No, go ahead, sir. Go ahead.
No, so then it should just work with that straight up.
Yeah, so as long as the and I mean, this is pretty much what often confuses organizations out there, that depending on what you're downloading, there is a different technology stack behind the scenes doing that download. What we're seeing today is that Microsoft is increasing heavily the type of traffic that goes over delivery optimization. And that also happened to be the most troublesome peering mechanism to configure. It's really difficult without an agent to get those really good peering efficiency numbers. Like I showed you earlier here in the main overview. But content is starting to get big. I don't know if you guys know this, but if you go to, say, get away. The Microsoft catalog site.
We had one question: what the Intune management looks like. I pasted one example of what the overall management of looking at the Intune autopilot piece looks like. And often the actual Intune tab for the remote stuff is mostly primarily around getting the device status as well as gathering all the logs for the Intune client for troubleshooting, etc.
If you take a look here at the latest updates, look at the size of them. They are the same size as Windows itself. And imagine that you have a network with 3,500 machines, and they were more or less all of them try to download this content on their own without a cache server, without peering. They will hammer that poor internet link. But obviously, the more peering you can get out of it, the less it will impact the WAN links and the internet links. And other content that is also using this is the regular Intune content. When you do updates from Intune, they are using delivery optimization behind the scene to download stuff. When you work with applications in Intune, they are using delivery optimization behind the scenes. So in this platform here, I think I have 600-700 apps that we deploy, some small, some large. Cache servers is used for this type of content, and peering is used for this type of content. And again, if you're deploying, say, Office, which is a 2 gig app, to an office with 3,000 machines through Intune, first you better have a lot of coffee because it's going to take a bit, but that is not delivery optimization's fault. It's just that Intune is a little bit slower as a platform. But we can make sure that that content is peered so that the download actually happens as quickly as it can be. Because the more content you can peer, the more effective it is over the wire. And we can make sure that it doesn't overload the WAN link either, or your internet link.
Yeah, I just pasted my dev machine has pulled down 6 gigs since the 1st of September.
It's a lot.
Yeah.
And I didn't mention this, but we have an optional feature that a couple of customers are super happy for. And we can make a note of everything that is ever downloaded ever in a SQL database. So I'm going to show you a really advanced SQL query here that I put together. I'm going to be so impressed, Andreas.
Oh, that is a complicated one.
Yeah, this is state-of-the-art SQL for you. But this one shows everything that has been downloaded. Which client that downloaded it, which particular type of content it was, whether that content was peering or not peering, what process was it that initiated this. So if you get a call from your network folks and say, hey, what did you guys do yesterday? Yeah, we did this yesterday, or whatever date that was. So you get that visibility historically back also. And we typically summarize this content on a daily basis, but even when you have a large number of machines, one of the customers I worked a lot with, they have about 100,000 clients. It can easily generate 20, 30 million downloads in a day or two. So it's interesting to see trends and see when things are working or not working. And this will give you that additional insight. Smaller customers, they will be happy to use a SQL Express database because it's 10 gig in size, the limit. Larger environments, they probably want to put in a full-blown SQL for it, but that is one of the features that is available as well. But I mean, to summarize a little bit, the ability to group your networks into different logical groupings, use templates to make sure they have assigned the right configuration to them, being able to see in real time everything that happens and whether your peering is good or not so good, if you need to make a tweak. That's pretty much the value of having that information. The remote tools I found very useful. And of course, we have all the other fun stuff that is available in the platform as well. And we have some upcoming webinars. For example, Matthias is doing a webinar shortly here on cache management. We have a new solution for that. We have DeployR, which is an imaging solution that Mr. Niehaus is heading the development of at the moment. But there is a lot of fun stuff being added into StifleR that was not available in the earlier version. Andreas, anything on your mind?
Yeah, I had a really interesting comment the other day where somebody asked me what I've seen in the trends within the last 20 years, and I would say that we're today seeing more congestion. Like if you have really poor bandwidth, yes, you'll still get congestion going to each site. But where we're seeing more and more issues with is that there's so many of these connections. Yes, they might have better individual connection to the data center, but then they're basically running out of either CPU or space out of a data center. We had one organization that we worked with, they managed to fill their entire data center out of Chicago that has a 40 gig connection. They managed to flood that entirely, obviously with a lot of clients, but going out over the internet. And obviously, like dedicating your 40 gig data center to updates is not typically what you want to do because you have a business to run as well. Luckily, this was on a weekend, so it was saved quite a lot by that. But I would say that proxies and data centers are today becoming the bottlenecks. Meanwhile, historically, in the olden days, it was more common to fill poor links.
Solid point, and I have to say it's pretty impressive to being able to fill up 40 gig of outbound traffic with updates. You have to.
Yep.
It's a commitment right there to
Yeah, sadly, it's a game where content size is getting bigger and bigger and bigger faster than networks are getting faster and faster. And the price point where your network, it's one thing to get 100 gig into your data center, but then to spread that effectively means that more or less every single switch has to be 100 gig downright, which is a very, very expensive exercise to do. I think we have some more questions. So it was regarding the time database. Yes, in the SQL side, we have some manual jobs that basically prunes out and summarizes the data, but we're also having a new database format that we're introducing where we'll take care of all of that and save X number of thousands or millions of recent jobs, and then we'll summarize those as well. Summarizing downloads is actually trickier than you think. So.
But it is nice to have that matrix going back in time, because it's always something you want to go back and review. And also trends is something I love to see, like, okay, we had this configuration back in March, we have this result. Then we made these couple of changes and now we see a much better result. But to having that, before and after type historic data is valuable. And also to have it in real time. I mean, Microsoft does offer some very, very basic metrics, for example, for an intern customer. But that it's like this much out of this much. And to say it's real time is, well, if you call 48 hours real time, then you can say it's real time, but otherwise, no. You learned today that you had a problem 2 days ago. Great. But this is valuable. All right. Any other questions?
I think my mic disconnected.
Well, if no more questions, Andreas, Karin, shall we wrap up?
Yep.
Yep.
Oh, well, first of all, thanks for having me. Thank you for allowing me to demo a bit for you guys here today. And definitely don't hesitate to reach out if you have any upcoming questions. As I mentioned, we have a whole series of webinars coming up now before Christmas. So Andreas, Karin, thank you. And for all of you that joined, also thank you.
Thank you.
Thank you.